Greetings once again, Theory 4 students. Today is Monday, April 27th, and once again it looks like it's going to be a nice day outside weather-wise. I hope you're able to get out sometime today and enjoy it. So this might be, this is probably the second to last lecture that I'm going to videotape for this course. My goal is to go through some practical, applicable examples with some atonal music. We're going to analyze some of it with what we know now with set theory. And because we know most everything we need to know, at least in this course about set theory, I think it's a high time that we go ahead and take a look at a piece and start analyzing it. My goal by the end of the week, I'm hoping by Friday, if not it'll be the following Monday, I'm going to send you one more lecture, and that lecture is going to be a review basically for the final exam. A review for the final exam. And right now, at least off the top of my head, I'm pretty sure that our final exam is scheduled for Wednesday, May 6th. I don't have exact or specific times just yet, but I do want you to put that on your calendar so that you're not working on that day necessarily, or that you'll have time to take the final exam, Wednesday, May 6th. And then also what I will be doing after this lecture is I will be uploading a final exam review for you on Canvas so that you can be working on that during the week. And then again, hopefully by the end of this week, I'll be able to go through that review with you through a lecture, and I'll be able to reveal all the answers so you can see how you did on that. But in the meantime, what I'm going to do, as I said, is we're going to take a look at a short example in your textbook, an atonal example, and we are going to find some normal orders. We're going to find some prime forms, and we're going to be able to start comparing some of these pitch class sets that we find in the piece to each other and see how similar they really are. What I have showing on the screen is some problems and some exercises that come from self-test 27.1 in your textbook. This is found on page 515. And although I'm not going to go through every single problem or exercise in this self-test, by the way, this would be excellent practice if you wanted to do some of these exercises, the ones I don't do in the self-test, because you do have the answers in the back of your book for these self-tests. Anyways, so I'd like to look at section C of the self-test, and these questions here are all about the very first musical example in chapter 27. That is example 27.1. I have referred to that example several times over the past several weeks. It's not a new example to us. And so anyways, we'll just get into that example a little more in detail, because we're going to start analyzing, we're going to start segmenting some pitch class sets, and then we're going to start finding those pitch class sets prime forms, or their set classes, to compare them. So number 1 in section C says, we saw in example 27.1 that the notes in the right hand in measure 3 are an inversion of the first 3 notes of the example, and the first 3 notes of the example are B, G sharp, and G. Well, If the notes in the right hand of measure 3 are an inversion of the first 3 notes of the example, this means they are members of the same set class. Remember, transpositions and inversions belong to the same set class. Okay. So this is asking us, what is the prime form for the notes in the right hand in measure 3? Whatever the prime form for those notes are, that will be the prime form of the first 3 notes of the example as well, because it tells us that the 2 pitch class sets are members of the same set class. Alright, so what I'm going to do is go back to example 27.1 in your book. I'll let you see that briefly here on the screen. You can also refer to that in your own text if you have that with you as you watch this lecture. And then we'll go through the process from taking an unordered set, just 3 notes out of an atonal piece, and going through the process to find the prime form. So here's example 27.1 on page 505 in your textbook. And the instructions or the exercise from the self-test that I just read asks us to find the prime form for these 3 melodic notes in measure 3 of the example. Namely, those notes are F natural, D flat, and E natural. And we are told that whatever the prime form of these 3 notes is, that is also the prime form of the first 3 notes of the example, because we're told that they belong to the same set class. So let's take these pitches, F, D flat, and E, and let me go to another screen and we'll start making the calculations to find the normal order, to find the inversion, and then eventually the prime form. So we said that the 3 pitches we're trying to find the prime form for are F, D flat, and E. And again, to find the normal order for an unordered set, we want to list all of the possible arrangements and find which arrangement of these pitches in ascending order within an octave is the most compact, or takes up the least amount of space from the first pitch class to the last pitch class. If I start with the D flat, that is probably going to end up being the normal form, but let's go through the process anyways. If I start with the D flat, the next pitch in ascending order within an octave is E, and the next pitch within ascending order within an octave is F. And the total number of half steps spanned from the first pitch class and the last pitch class in this arrangement happens to be, it's a major third in terms of traditional intervals, and that is a distance of, should be a distance of 4 half steps, or 4 semitones. The other 2 possible arrangements of these 3 pitch classes in ascending order within an octave are not going to be the normal order. For instance, if I start with E, then my next pitch would be F, and my last pitch would be D flat. And you can see that the distance between the first pitch class and the last pitch class in this arrangement is much larger than the 4 semitones spanned in this arrangement. Also, the only other possibility or arrangement would be to start with the F, and then my 3 pitch classes would be ordered in this fashion. And once again, I have a very large interval of distance between the first and the last pitch classes in that arrangement too. So this arrangement here is definitely going to be my normal order for the set. Okay. So let's turn these pitch classes into pitch class integers rather than pitch letter names. And it looks like my normal order is going to be, and I use square brackets for this, D flat belongs to pitch class 1, E belongs to pitch class 4, and F belongs to is pitch class 5. Okay, so my normal order for these three pitches is 1, 4, 5. That is one step in the process of finding the prime form for this set class, or for this pitch set. We haven't found the set class yet. Okay. So one thing I need to do to get closer towards finding the prime form is I need to rewrite this set so that the first integer starts with 0. In other words, I need to subtract a 1, or the smallest integer from these numbers right here in this set. I need to subtract 1 from all the members of the set, and that way I'm guaranteed that the set will start with 0. And transposing does not knock a set out of normal order. The set will remain in normal order even when transposing. So 1 minus 1 is 0, 4 minus 1 is 3, and 5 minus 1 is 4. There I have the normal order where it's reduced to start with a 0. And that's one of the main things I want. The next thing is to find the inversion of this set so that the inversion will also begin with a 0. So what I do then is I subtract all of the integers of this set from the largest member of the set. In other words, I'm going to take the 4 and go 4 minus 0, 4 minus 3, and 4 minus 4. When I do that, it will knock the set out of normal order, and 4 minus 0 is 4, 4 minus 3 is 1, and 4 minus 4 is 0. Once again, inverting a set 95% of the time is going to place the set in the exact reverse normal order. So what I need to do is just switch these numbers around so that they start with the 0. And I will have the normal order of the inversion, which is what this is, the inversion. Okay, so the normal order of the inversion is 0, 1, and 4. Comparing these two sets, this one and this one, which pitch class set yields the smallest sum when you add the pitch class integers of each set together? Well, 4 plus 3 equals 7. 4 plus 1 equals 5. So this version yields the smallest sum, and that means that 0, 1, 4 is going to be my prime form for this group of three pitches, F, D flat, and E. And I would list that as, again, curvy parentheses with no commas, 0, 1, 4. This is my final answer for the prime form. So, let's go back to the music now, and let's go ahead and mark that the pitch class set that we segmented there as the prime form of the set class 0, 1, 4. So we just found the prime form for these three melodic pitches in measure 3. So I'm going to put the prime form right next to that group of pitches. In my music, it is 0, 1, 4. What that also means is because of the question or exercise in section C of the self-test, we also know that these three pitches belong to the same set class as the first three pitches of the piece. So we know, for instance, then that B, G sharp, and G, they belong to the set class 0, 1, 4, because their prime form will also be 0, 1, 4. So we can already start to see, even in the first three measures of this example, we can already start to see some similarities. That these three pitches are very closely related. In fact, they belong to the same set class as these three melodic pitches do. And before this lecture is done, we're going to find several more pitch class sets that are belong to the exact same set class as 0, 1, 4. For the next group, what I'd like to do is, how about let's find the set class, or the prime form, for these three circled vertical notes in measure 3. In other words, for this vertical harmony in measure 3. You can see that these pitches are B flat, A natural, and D flat. Again, let me go to another screen and start with the unordered pitches B flat, A natural, and D flat, and find the prime form. So we're starting out with B flat, A natural, and D flat. Okay. I'm seeking out normal order for these three pitch classes first. One way to arrange these three pitch classes is to maybe start with the B flat, and then I would have, in ascending order within an octave, I would have B flat, D flat, and A, and that's a pretty large span between the outermost notes of that arrangement. Another arrangement would be to start with the A, and in that case I would have A, B flat, and D flat, and this looks pretty good. In fact, I'm going to calculate how many half steps there are between A and D flat. Once again, you can think of the D flat enharmonically as C sharp if you'd like. A to C sharp is a major third traditionally, and we know major thirds have a total of 4 half steps in them. The only other arrangement I can get from these three pitches is to start with the D flat. And if I did that, I would get D flat and A and then B flat. And once again, I'd have a larger interval between the outside pitches. So it looks like this middle one is my normal order for the pitch class set. And let's go ahead and turn those pitch classes from letter names into integers. And why don't I just write it over here. A is pitch class 9. B flat is pitch class 10. And D flat is pitch class 1. So my normal order for these three pitches that I started with is 9, 10, and 1. Reducing this set so that it starts with a 0, I'm going to subtract 9 from each member of this set. 9 minus 9 is 0. 10 minus 9 is 1. And 1 minus 9 gives me negative 8. But that's not within my perfect range of 0 to 11. So if I have negative 8, what I need to do is I need to add an octave or add 12 semitones to that number until I get the number within or between 0 and 11. So negative 8 plus positive 12 gives me a grand total sum of 4. Negative 8 plus 12 is positive 4. And it looks like my normal order for this set that starts with a 0 is 0, 1, 4 again. Well, based on what we've already done earlier in this lecture, 0, 1, 4 is going to be the smallest, most compact version of this set, even when you include all the transpositions and you were to look at all of the inversions in transposition as well. If I were to invert this set, I would basically get a normal order of 0, 3, 4. And once again, I compare 0, 3, 4 with 0, 1, 4. And 0, 1, 4 is indeed going to be the prime form. So I hope it's okay that I don't go through the inversion process in this example, because I know that 0, 1, 4 is in the appendix in the back of your book, and that is the name of a valid set class. That is a correct prime form. So I'm going to list the prime form for these three pitches up top again as 0, 1, 4. And I will mark that on the music right next to these three pitch classes so that I've got that labeled and analyzed in the piece. So 0, 1, 4 is the prime form for this vertical chord in measure 3. And now you can see that we found also even more similarities of pitch groupings with the opening three pitches of the example. We have the composer, by the way, Schoenberg, has used pitches from the set class 0, 1, 4 here. He's used it here and melodically in measure 3 and also harmonically in measure 3. Talk about some close relationships. You can start to see now why, even in atonal music, this isn't necessarily just a random bunch of notes haphazardly splatted on the screen or splatted on some staves to make music. Even though it may sound a little random or haphazard, it really is not, and there are close relationships between groups of pitches. We just have to go looking for them. Maybe a few more pitch classes to identify the prime forms of. In measure 4 and in measure 5, we have these long sustained notes that are tied across the bar line. There are two up here in the treble staff, and there's actually one down here in the bass staff. And if you look closely at these pitches, you'll notice that the pitches are B, G sharp, and G. Well, are not those three pitch classes, B, G sharp, and G, the same three pitch classes? In fact, they're identical to the pitch classes at the very beginning of the example. Sure enough, they are. You can see B, G sharp, G, same as here. If you can kind of see the way I segmented or put a circle around these longer sustained notes across the bar line from measure 4 into measure 5, B, G sharp, and G natural. Do I need to go through the process to find the normal order, the inversion, and then therefore the prime form of this pitch class set? No, I don't, because these pitch classes are identical to the first three pitch classes, and these three pitch classes belong to set class 0, 1, 4. So I don't need to go through the whole process there. However, there are three more pitches down in the left hand, starting in measure 4, going across to measure 5, that I do want to analyze closer and find the prime form for. And those three pitches are this F sharp eighth note, then an A, and then an A sharp. F sharp, A, and A sharp. Let's find the set class of those three pitches. F sharp, A, and A sharp. Currently, it's an unordered set. I don't know if you are getting enough experience and enough practice to start maybe looking at a pitch class set, especially small pitch class sets that only have like 3 members. Can you kind of envision what order or what arrangement of these 3 pitches on a staff will give us the shortest possible distance between the first note and the last note of that arrangement? Well, it looks like to me that if I start with the F sharp and I list the rest of the pitch classes in ascending order within an octave, I would get A, and then I would get A sharp, and this arrangement is again going to be the most compact arrangement of these 3 pitch classes. F sharp to A sharp is again traditionally a major third. Boy, I'm seeing a pattern here. And a major third always contains 4 semitones. So that's the total distance in half steps from the first pitch of this arrangement to the last pitch of the arrangement. And I'm not going to even bother writing out the remaining arrangements, because I know that the distance from the first pitch to the last pitch in those arrangements will be larger than 4 half steps. Writing the normal order then for these 3 pitch classes and using pitch class integers. F sharp belongs to pitch class 6, A is pitch class 9, and A sharp is pitch class 10. Reducing this normal order down so that it starts with a 0. I subtract 6 from every member of this normal order set. 6 minus 6 is 0. 9 minus 6 is 3. 10 minus 6 is 4. One of the first sets that we found the prime form for, we ended up with a 0, 3, 4 somewhere in our calculations. Well, 0, 3, 4, when I invert that set, which I'm supposed to do next, I will subtract all of these pitches from 4, and I will get another unordered set, which I'll write over here. The inversion would then be 4 minus 0 is 4, 4 minus 3 is 1, and 4 minus 4 is 0. Rewriting this inverted set in the reverse order to put it in normal form, I will get, once again, 0, 1, 4. We've been down this road before. Which of these 2 pitch class sets yields the smallest sum when you add their integers together? Well, 4 plus 3 is 7, 4 plus 1 is 5. So once again, this is going to be our normal order, our prime form, for the original set, F sharp, A, and A sharp. And I would list the prime form without commas, 0, 1, 4. And then I would put that on the music, so I have my label, I've got it analyzed, I don't need to do the work for that particular set, pitch class set any longer. So here we have, this was this pitch class set F sharp, A, and A sharp, kind of in the tenor voice, tucked in there in measures 4 and 5. And I already know now that the prime form of that pitch class set is 0, 1, 4. And it looks like I failed to list the prime form for this other set, even though we didn't go through the calculations for it. But I know that it's 0, 1, 4 because it is the pitches B, G sharp, and G. All right. Let's do one more segmentation, one more group of pitches for a pitch class set in this example, and then we'll move on from there. So if you have your book open to page 505, if you want to turn the page to page 506, there's a little bit more of the excerpt on the top of page 506, and the last 3-note pitch class set that I want to analyze for prime form, or for set class, is the 3 melodic notes in measure 10. Here we have the pitches C, G sharp, and A. C, G sharp, and A. I believe I said C, G sharp, and A. Yes. Okay. Finding the normal order of these 3 pitches, if I start with C, I'm going to get, in fact, this exact order, C, G sharp, and A. And it looks like that has a total distance between the outside pitches of 9 half steps. Another arrangement in ascending order within an octave is to start with the G sharp. Here I would have G sharp, A, and C. And G sharp up to C is once again a total of 4 half steps. 4 half steps. For instance, you can think of the G sharp as A flat enharmonically, and A flat to C is a major third, and once again, that tells us we have a total distance of 4 half steps. The other arrangement, if I start with A, I'm going to get another large outside interval. So I can write it here. It's going to be A, C, and then the G sharp way up here. And in fact, that outside interval looks like it's just a half step shy of an octave. So it's going to be 11 half steps, and that's certainly not going to be the the normal form arrangement. So my normal form for this unordered pitch class setup here happens to be G sharp, A, and C, and I'll list that using pitch class integers. So G sharp looks like that is pitch class 8, A is pitch class 9, and C is pitch class 0. Reducing this normal order so that it starts with 0, I subtract 8 from every member of the set. And 8 minus 8 is 0, 9 minus 8 is 1, and 0, think of 0 as, well, you can go 0 minus 8 and get negative 8, and then add 12, and you would get 4, positive 4. Another way you could do this is just think of 0 as 12 right off the bat, because it's the same thing as 12, and 12 minus 8 is 4. Either way, we're left with a normal order that starts with 0 of 0, 1, 4. Do I need to go through the work of finding the inversion and its normal form? No, I don't, because I know that 0, 1, 4 is the smallest reduced version of these 3 pitch classes I can find, including transpositions and inversions. So I know that my prime form or set class for these 3 pitches is once again 0, 1, 4. And that's how I would label it. And I'll finally put it on next to these segmented pitches on the music. So the 3 melodic pitches in measure 10 belong to set class 0, 1, 4. There we go. Now, I don't have time to, probably you don't either, but we don't have time to segment and go through every single group of pitches in this short 11 measure example. But what we have done thus far shows to us and demonstrates to us that Schoenberg is using a lot of related pitch class sets. He's very fond, at least in this piece, of the set class 0, 1, 4. And he's using different transpositions and different inversions of those 3 pitch classes, but they all boil down to the prime form 0, 1, 4, and that's how we can see that these pitch class groups are related. Again, we would not be able to see or determine all these similarities unless we went through the calculations and the process that we now know about set theory. Okay, let me see, let's just talk about how much we've covered here in section C. We did find the answer to number 1. The prime form for the notes in the right hand of measure 3, F, D flat, and E, that prime form was 0, 1, 4. And yes, it is a member of the same set class because the prime form of B, G sharp, G, the first 3 notes of the example was also 0, 1, 4. Number 2 says, list some other occurrences of this set class in the excerpt. Well, we listed a bunch. We found several. And I hope you put that in your book or took that down, information down in your notes. It says, put your answers in, try to make your segmentations musically defensible. Okay, I don't think we need to worry too much about that. But section C, number 3, which of those occurrences of 0, 1, 4 did we find use the same exact pitch classes as the opening 3 notes? Well, that was that pitch class set that I segmented between the end of measure 4 and into measure 5, with the tied notes. Remember the exact pitch classes were the same. Whoa. Go ahead and freeze it so that the page doesn't slip on me. But the exact pitch classes we found, B, G sharp, and G at that moment, they were the same as the first three pitches of the example, B, G sharp, and G. I'd like to go through one exercise in section D, and that's actually on the next page. So let me skip to that. Alright, so this is the following page. This is page 516 in your text. And I guess with the one I'd like to do, because we don't have time to do all of them, let me find that one, is I think I'd like to look at number 5 here in section D. Number 5 asks, what is the normal form, the prime form, and the fort name of the recurring 5-note figure in the tenor in measures 4 to 8? And then the question is it inversionally symmetrical? Well, let's not worry about this last question right now. Let's just deal with the basics that it's asking me right up front here. What is the normal form, prime form, and fort name of the recurring 5-note figure in the tenor in measures 4 to 8? Let's go back to that same example. So starting in measure 4, let me increase the size of this so you can see it just a little better. We are being asked, what is the normal form and the prime form of these 1, 2, 3, 4, 5, these 5 eighth notes that occur in the tenor voice range? Okay. We've already found the prime form for 3 of these notes, but we did not treat this area here as an entire set class of 5 pitches before. So now we're going to have to, again, start from scratch. D, F sharp, A sharp, and B natural. And now we're dealing with a larger set, but that's okay. We still know how to manipulate and do our calculations with pitch class sets that contain 5 members, which this one will. Just to show you, this same set class, or this same idea, shows up also in the tenor voice in measure 6 and in measure 8. If you can see that from your vantage point, here in measure 6 in the tenor range, I have those 5 pitch classes as eighth notes again. D, F sharp, A sharp, B natural. And it occurs also in the tenor voice of measure 8, D, F sharp, A sharp, and B natural. So I think it's kind of an important pitch class set to analyze and find the prime form for, especially because it occurs 3 times in this short example, and it includes the same exact pitch classes each time. Alright, so let's find the normal order first and then the prime form for these 5 pitches. Let me make a little space here so I can start from the beginning. Alright, this time I brought my book with me because I wouldn't remember those 5 pitches if my life depended on it. Okay, so D was 1. Then we had F sharp, then A sharp, and then finally B, or B natural. Okay, a bigger set, but we can still find the normal order and the prime form the same way that we have learned for all the other types of sets we've dealt with. So let's start with an arrangement here. How about starting just with the D? So D, and then F sharp, and then A sharp, and then B. That is going to be a total distance between the first note and the last note, that looks like a major sixth traditionally, a D to a B. And a major sixth should contain 9 half steps. Another arrangement would be to start with the F sharp. So we have F sharp, A sharp, B, and a D. And if I copied those down correctly, it looks like the distance between the outermost notes in this arrangement is F sharp to D. That is a minor sixth traditionally, and that contains 8 half steps. Okay. Starting with the A, I would get A sharp, B, D, and F sharp. And the distance between the outermost notes in half steps, A to F sharp, that is another traditional major sixth, so that would be 9 half steps. Another arrangement would be to start with the A sharp. So we'd have A sharp and B, and then D, and then F sharp, and then A. And we know from A sharp to A natural, that is a half step shy of a full octave. So this would be 11 half steps. And then finally, starting with the B, let me notate it down here. I'd have B first, and then D, and F sharp, and A, and then A sharp. And the total distance span here is B to A sharp is a semitone shy of a full octave. So this would be 11 half steps as well. So after all the arrangements, I boiled it down to, it looks like this arrangement is going to be my normal order. Okay? The arrangement that starts with the F sharp and ends on D. And let me go ahead and write that in terms of pitch class integers. So F sharp is pitch class 6, A is pitch class 9, A sharp is pitch class 10, B is pitch class 11, and D is pitch class 2. 6, 9, 10, 11, and 2 is my normal form. Gosh, I'm wondering, yeah, maybe I'll just show you the shortcut method so that you don't have to write out all 5 of these arrangements. If I just take all these arrangements away, but leave my normal order, what I'll find is, again, start with any pitch and write them in ascending order within an octave. F sharp, A sharp, and B, and then duplicate or reproduce the first pitch class at the end of the set, or at the end of the arrangement, but an octave higher. Okay? Now, when you do that, now you want to look between all the successive pitches or adjacent pitches in this set, and you need to find the largest interval between any 2 adjacent pitches. Well, we have D to F sharp that looks pretty big. That's 4 half steps. F sharp to A, that's a minor third. That's only 3. That's not going to be a large interval. These 2 pitches don't form a large interval. And these 2 consecutive pitches, B to D, they form a minor third again, which is only 3 half steps. So the largest interval between any 2 consecutive pitches in this arrangement is this first one right here, D to F sharp, which is 4 half steps. And again, in the shortcut method that I'm working on here for finding normal order, all I do now is rewrite this arrangement, but start with the higher note of the 2 that I bracketed. Start with the F sharp, and everything should be in normal order from that point on. So if I rewrite it as F sharp, and A sharp, and B, and D, this turns out to be my normal order. And you can see that I have the pitch class integers for that right here. 6, 9, 10, 11, and 2. So it doesn't matter which method you use to find the normal order. Whatever method you use, if you use it correctly, you would still come up with the same answer. Alright, let's move on to finding the prime form of this large set now. Reducing this set so that the first integer is 0. I'm going to subtract 6 from every member of the set. And that'll still be in normal order. 6 minus 6 is 0, 9 minus 6 is 3, 10 minus 6 is 4, 11 minus 6 is 5, and well, 2 minus 6 is negative 4. That's too small of a number. I need to get it within the range always of between 0 and 11. So negative 4, I add 12 to that, and I would get positive 8. So the normal order of this unordered set we got from the example in the book that starts with 0 is 0, 3, 4, 5, 8. Let's now check for the inversion and put the inversion in normal order and find out which, either this set or the inversion in normal order, which is smaller. Okay, so I'm going to have to do that over here. Let's subtract, to get the inversion, subtract, that starts with 0, subtract all of these members of this set from the largest pitch class, and that is subtract them all from 8. Alright, so 8 minus 0 is 8. 8 minus 3 is 5. 8 minus 4 is 4. 8 minus 5 is 3. And 8 minus 8 is 0. So this is the inversion in reverse normal order. Putting the inversion in normal order, I just rewrite it the other way around, starting with 0. 0, 3, 4, 5, 8. Let's compare these two. It looks to me like they're identical. If I were to add the pitch class integers of each of these sets, 8 and 5 is 13, plus 4 is 17, plus 3 is 20. And here I would get 7 plus 5 is 12, plus 8 is also 20. So, what is the prime form for our original 5 pitch set? Well, the normal order has to be this, because it's the same in both cases. And that is 0, 3, 4, 5, and 8. So let me mark that on the music. Let's do it here. If I mark these, that gives me 0, 3, 4, 5, 8. And if I mark this grouping of 5 pitches here, which is the same, that set class is also 0, 3, 4, 5, 8. And if I go back to measures 4 and 5 on page 505, then I know that all 5 of these pitches in the tenor voice belong to the set class 0, 3, 4, 5, and 8. Let's go back to the self-test, section D, number 5, and look at the question again to see if we've got what we need now. Okay. Number 5 asked us, what is the normal form, prime form, and fortnate of the recurring 5-note figure in the tenor in measures 4 to 8? Well, we know that the normal form, well, we found that on the other screen. We know especially that the prime form is 0, 3, 4, 5, 8, I believe. And for the fortname, again, I don't require you to do that, and I won't be requiring you to do it on the final exam. But we can always find the exact fortname in the appendix in the back of the book. So let's go to the appendix right now, look up the prime form 0, 3, 4, 5, 8, and yeah, take a look at the fort name.